Greetings, everybody. Today we are going to talk about thermochemical equations and be able to solve thermochemical equations given grams and determining how much heat is produced or released or absorbed for exothermic and endothermic reactions. So these can be a little bit tricky because of the fact of some formatting issues that come up. So let's go over a couple ways in which exothermic reactions can be represented in a chemical equation. Remember, delta H is going to be a negative number. In addition to that, if the heat is inside the formula, you're not going to see a negative number. The heat, the amount, will be placed on the product side. It will be in the positive format. But please note that since it's being released, it's part of the product. So heat is being released. All right. Alternatively, in endothermic reactions, when it's represented, delta H is always positive. However, for endothermic reactions, if the numerical value is inside the formula, it can also be represented. But instead of being produced, it's going to be consumed or absorbed. So therefore, our heat, it's going to be in the positive value again, is going to be on the left-hand side. So please remember, just because the heat is positive, if the heat is incorporated in the equation and it's positive and it's on the product side, it's going to be exothermic. If the heat is on the reactant side inside the formula, it's going to be endothermic. All right, so here's our equation. We have 2 sulfur plus 3 oxygen produce 2 sulfur trioxide, and we have some heat listed here. Now it's inside the formula. However, it's on the right-hand side. It was released. Therefore, what is my delta H? My delta H is, survey says, negative 791.4. It's negative because it's on the right-hand side of the formula. Is it exo or endo? It's a product, so it's going to be a release. So it's going to be not endo, but rather exo. All right, what happens if we reverse the formula? And the same exact thing, but we reverse the products and put them on the reactants, and reactants become products. Well, remember that the positive or the negative symbol does not mean that it has a small amount of heat. It just means the direction of heat flow. So if the heat is now inside the formula on the left-hand side or the beginning, that means it's being absorbed. And so we're going to have a positive 791.4 kilojoules of heat. Additionally, if it's on the left-hand side and it's in the formula, it has to be in the formula on the left-hand side. It's going to be absorbed, therefore it's going to be endothermic reaction. Well, here's a fastball for you. What happens if we flip and half the coefficients? So this is what we start with. Remember, this is our beginning formula. What happens if we flip it and have half the amount? Well, what's my heat gonna be if we flip it? Well, I know that now that my heat is on the left-hand side, I do know that's going to be positive because it's being absorbed, and I do know that's going to be endothermic. But since half of the atoms are there, therefore half the heat is there. So let's get our eraser out and figure out how much heat is there. So we have 791.4 divided by 2. So we should have 395.7 So 395.7. Okay, perfect. Again, if it was doubled, then you'd have twice the heat. But since we halved it, we'd add half the heat. All right, last problem here. How much heat will be released? Okay, so again, we have a certain amount of sulfur. So we have 6.44 grams of sulfur, and we're trying to figure out, well, this is excess oxygen. This is going to be our excess reactant, so we're going to have unlimited oxygen. And why is it not? All right, so again, we have 6.44 grams of sulfur. We have unlimited, or the excess oxygen, and we're trying to figure out, well, how much does 6.44 grams actually produce, or actually produce how much heat? So let's do some stoichiometry. So we are going to go from grams. This is the process that we're going to do. We're going to do grams. Remember, we're always going to do moles, and then we're going to do heat. Okay, so we have 6.44 grams of sulfur. Grams of sulfur is on top, grams of sulfur is on the bottom. And on the periodic table, sulfur weighs 32 grams. Now, this is the tricky part. Don't let this mess you up. How many sulfurs are there? We know that moles of sulfur is going to go on the bottom, but let's go. This is where we make the handoff. There are 2 sulfurs for how much heat? This is the second part in which people make mistakes with. The first mistake, people always forget to put a 2 there based upon the coefficient. The second mistake is students do this. Not correct. Remember, if the heat is on the right-hand side, it is exothermic. So it's going to be a negative. So the second mistake students make is forget to put that negative sign if the heat is on the right-hand side of the products. So you multiply the tops, divide by the bottoms, and moles, grams, grams, which leaves us with negative 79.6 kilojoules of heat. Okay, so if you have that much mass, this is how much heat is going to be released.